Thank you everybody for coming and welcome to the 51 Plugins workshop on authoring data-centric AI applications. So if you're here, that means you probably know what 51 is. You may not know what a plugin is or how it can help you. We're going to get into all that shortly. So to cut to the chase, I don't want to belabor it, but the most important thing that I hope you take away from this entire workshop is that plugins will save you time and help you to get to production faster. So plugins allow you to streamline your workflows, to encapsulate blocks of code, logic sequences, any user interactions and dynamic patterns into repeatable, reproducible sequences that you can then use and share. And plugins are incredibly flexible, and they will allow you to do so much from traditional computer vision and machine learning workflows to creating your own really custom AI applications. Before we get into all of that stuff, I just want to give you a little taste of what's to come. So when I say helping you streamline your workflows, this is just an example of that. So let's say I am working with a synthetic data set. I've been adding images to my data set. In this case, I have a bunch of images from DALL-E and Stable Diffusion, but they can be from whatever text to image generation model or whatever other source you'd like. And the final image that I generated is an image of an excavator. So it's this machine over here. And let's say I want to add a segmentation mask to that machine. Normally, this would be a pretty arduous process. It might require me writing custom code or searching online, downloading a custom model, and then trying to figure out how to match the formats and all of that. But with 51 plugins, it's so much simpler. So I can look at the plugins that the community already has built. I can search through and find one that matches what I need. In this case, a zero-shot prediction plugin. I can select the sample. I can go to that plugin, the operator for that plugin that I have just installed. I can select the task. So in this case, I want to do an instance segmentation task. I can type in the label, and it will generate a segmentation mask for that object. So in this case, it did it in just 20 seconds from start to finish. I was able to go from having nothing to generating a segmentation mask. Here's another one. So let's say I want to deduplicate my data. I have a bunch of images, and in this case, they're from CFAR, and I have some duplicates in there. So I've corrupted some of the data to add some duplicates to this data set. And sometimes they're right next to each other. So at the top left of this image right here, we can see two copies. But then there's sometimes when the images are not next to each other. So here we have two other copies of the same image over here, and so forth and so on. Like we don't want to have to go through the entire data set one by one and catch all the duplicates by hand. That's not efficient. Well, we can use a plugin. So here, let's go to the install plugins operator again. We'll look at the community. We'll find an image duplication plugin, and we will run that. And we can see first, we can get all of the duplicates. So here we're going to find exact duplicates. And then we can display the duplicates. So this will just show us all of the groups. And here we can see their pairs of duplicates. And then we can, again, with a single click, we can remove or deduplicate those duplicates. So those are just two examples, and those are very practical examples, but there's really so much more that you can do with these things. You can build incredibly custom applications, and that's what we're going to talk about today. We're going to talk about everything from the very basics, what a plugin is, how it works, how to use them, to how to build your own. And on a high level, this workshop will be structured as followed. We're going to do some very brief housekeeping to start. Then we're going to do part one, which is going to be about using and installing 51 plugins. So we will do an overview of what plugins are, and then we will get hands-on. And I will walk you through in the 51 app, actually using and installing plugins. Then we'll go to a short break. So we'll take about 5 minutes. If you need to, you can go to the bathroom, whatever else. And then after that 5-minute break, we will reconvene and we will talk about developing plugins. So the second part of this workshop will be about developing your own plugins. We will do an overview of how to develop, the structure for developing plugins, and then we will actually get hands-on and develop a plugin together. We'll conclude with some very brief next steps. So for some quick housekeeping, my name is Jacob. I am a machine learning engineer at Voxel 51. Voxel 51 is a data-centric AI company whose mission is to bring transparency and clarity to the world's data. We want to ensure data quality and to enable data-centric workflows. To that end, we've built FiftyOne, which is a toolset that is open source, and it is for visualizing, cleaning, and curating your data, for finding hidden structure, for evaluating models, and for doing tons of other machine learning and computer vision workflows. It fits in and connects to the greater machine learning and computer vision ecosystem, everything from datasets to models, experiment tracking, and machine learning frameworks. And more concretely, you can think about it as the link between your data and your models. I also see a question in the Q&A. Thank you. I will get to that at the break between this second and the next one. So prerequisites, who is this workshop for? This workshop is for data engineers, data scientists, machine learning engineers, and in general, anybody who wants to build custom interactive AI and computer vision workflows and applications. This is about FiftyOne plugins, how to use them, install them, and build with them. This is not FiftyOne 101. Now, if you want a more basic, a more introductory FiftyOne 101 workshop, you can go to the Getting Started with FiftyOne workshop, which will be taking place on December 6th. And Jimmy will be posting a link in the chat. And you can also see all of the events that we have upcoming on the voxel51.com website at voxel51.com/events. Now, this is going to be a hands-on workshop. So this requires that you have a working Python installation and FiftyOne installed. So FiftyOne is compatible with Python version 3.7 through 3.10. So you should have one of those installed. You can use your base Python installation that comes with your computer, or you can, as we recommend, use a virtual VM or Conda environment. By the time we get to using the app, which will be relatively shortly, should have FiftyOne installed. So pip install FiftyOne if you haven't already. And we will also be using a dataset. We will be looking at a dataset in the app. So if you need to, you should do import FiftyOne. You should import the FiftyOne zoo as FOZ, and then download the quick start dataset with FOZ.loadzoo dataset, and then in quotations, quick start. That's all you will need before we get started. Awesome. So a quick overview of plugins. So one of the things that we emphasize a lot in the Getting Started workshop is just how flexible FiftyOne is. So it allows you to do so much. It allows you to really build out your own workflows however you'd like. The app itself, the FiftyOne app, which is what we're looking at right now, is a wrapper around, and it is a UI around the Python SDK, which allows you to programmatically query and filter your computer vision data and to perform operations on that. Now, as we built out this flexibility, as we realized how flexible it was, and we got requests from open source users and paying customers and other people in the community, we kept on adding more and more functionality natively into the FiftyOne app. So in this case, it was a button here. So this magnifying glass button, when you click on it, you can type into a text bar. And in this case, we are typing in a text query for here, animals. And then it is doing a semantic search using that text. So it is embedding that text query, and it is running a query against the image embeddings for the images in our data set and returning to us the most similar images that match that text query. So high level, added a button to perform a computation and to return a result to us. Here's another example of some flexibility that we added natively to the app upon request from our open source community. So this is a sample visualizer for 3D data. And in this case, we were looking at a subset of the kitty dataset. And so we are looking at scenes. These are grouped datasets. So we have groups of left and right stereo images along with a 3D visualization of the LiDAR. And we can see these 3D bounding boxes here. So the 3D visualization itself is a new sample visualizer, and that was added as an option for 3D data into the app. And here's one more example. So in this case, we're looking at a custom panel. And this panel allows you to dynamically filter your data based on location. So here we are choosing, using a couple of points that we're selecting, a grid area in Manhattan, and we are seeing all of the images whose samples are located or were captured in that particular area in Manhattan. So this is dynamically filtering our data based on user interaction in a custom panel. Now, all of these were things that we added into the app for certain types of data sets, but this made just one thing incredibly and abundantly clear. It was that this is a super flexible framework, and the most important thing to do moving forward wasn't to add specific things into the app. It was to expose all of this functionality to the end user, so the user can actually build their own sample visualizers and panels and buttons and workflows. And that's what we did. So plugins harness this flexibility. And this is just a smattering of some of the plugins that exist right now. This is just a small subset of the plugins that exist and can exist and will exist. So we have plugins for everything from the ones I showed you for zero-shot prediction to things like model comparison and keyword search, evaluation, I/O, audio retrieval, all of these things. Small subset, but this just shows you a small set of what is possible with FiftyOne plugins. Before we get into specific examples of plugins and we show you how they work, I just wanted to talk about what's going on behind the hood a little bit. So the atomic element of a plugin is an operator. An operator is something that allows you to trigger custom workflows directly from the app via custom forms. So here we are looking at an operator in the visual on the right-hand side here, and this operator is wrapping the functionality for compute visualization. So this is what allows us to take embeddings for our samples and to use dimension reduction on them with UMAP, TSNE, or PCA to make that visualizable in 2 or 3 dimensions. These operators are modular, interoperable, composable. You can write them in Python or JavaScript. They have an incredibly rich type system, which we'll talk about shortly. And you can use them in asynchronous mode. You can even delegate their execution to happen on another device or at a later time. We also have plugins that allow you to register components which can override the built-in sample visualizer. So here we have a plugin that was contributed by a community member, which makes the FiftyOne sample visualizer compatible with 2D line data. So here it actually uses the eCharts module. And this allows you to basically, when you click on a sample in the grid, if it has this XY data associated with it, it will pull up this interactive eChart. And we also have panels. So you can, the same way as we had the geolocation panel where you could filter by a certain area in that panel, you can create custom panels that have whatever workflows you want. So here we have a panel that allows you to paste a link to a YouTube video and then watch that YouTube video within the FiftyOne app. At a high level, plugins are structured like this. So we have operators, which are the atomic elements, and operators can be defined in Python or JavaScript. In JavaScript, you can also define components. So you can make custom components using React Material UI, you can use HTML, and you can define your own UI. You can create plugins that have Python, plugins that have JavaScript, plugins that have both Python and JavaScript. Roughly, the way that we like to think about it is Python is what allows you to run these custom computations. JavaScript is for handling a lot of the dynamic and more complicated user interaction. But of course, that delineation is not strict. Today, we're going to be talking about Python plugin development. Now, if you'd like, we can do a follow-up workshop on developing JavaScript plugins, but that is a little bit more involved on the JavaScript side. And I am not a JavaScript programmer first and foremost. We are happy to do that. But today we're going to start with the basics and just talk about how to build operators to trigger these custom workflows. So here are a couple examples of plugins that you can make. Here is an AI art gallery plugin, which allows you to choose from a bunch of text to image models, Stable Diffusion, SDXL, DALL-E 2, and since then we've actually added DALL-E 3 and SSD 1B and latent consistency models. It's really easy to, once you've built a plugin, to customize it, to add more functionality as you go. So here we are triggering this operator from our operators list. We are selecting it. We are choosing the model. We are entering a prompt. We can add whatever other additional information we'd like. And we specify all this in the design of the operator in our plugin. And we are executing this, and we've added an image to the dataset. So you can do this to add synthetic data to your dataset. You can build a reverse image search application incredibly easily. So you can paste in a link, and then you can search for similar images in your dataset with respect to that link, or you can drag and drop an image from your desktop and search with respect to that. You can go multimodal. So this is a video here showing with ImageBind, a model from Meta, which embeds 5 different modalities all into one space together. So here what we're doing is we are taking an audio file, and this is an audio file of a train, and we are embedding that, and we are searching our images with respect to that audio. So the details computationally for what's going on here are unimportant for this very moment. The important thing is that you can use multiple modalities. You can really mix and match this, and this is not just for computer vision data. This is really for any data that you can visualize and you want to dynamically and interactively work with. You can create new workflows. So everything I've shown you so far are pretty typical workflows that you would see and that you can see if you look at blogs or LinkedIn posts or whatever other machine learning resources you'd like. But you can also create your own dynamic workflows depending on your data, things that you maybe want to do just to experiment with and to explore your data more, or things that are more concretely bringing value to you and your company. So in this case, we are traversing the space of concepts. We are starting from an image of a pizza, and we are adding the text concepts for healthy and colorful. And behind the scenes, this is doing a multimodal vector search, and it is taking this destination vector that we have generated and querying our images with respect to that, and returning the most similar images to this destination vector that we have generated. But that is beside the point. The important thing here is that you can create custom workflows. You can visualize your natural language understanding. So here we have a PDF document. We are looking at the pages from that. And we have run OCR on this. So we have little blocks of text that have been identified by the optical character recognition engine. And then we can create an index and semantically search these blocks of text. So here, this is very similar to if you've seen like documentation searches, if you've seen people do things like making their documentation semantically searchable. This is basically that, but visual and much more interactive. And you can combine plugins. So the last plugin I showed you actually was the last GIF I showed you was actually a combination of 3 plugins. There was a PDF loader plugin, there was a plugin for doing optical character recognition, and then there was a plugin for doing the semantic document search. Here, we are also combining 3 plugins together. So first, we are adding an image to the dataset using the text to image operator. Then we are using a visual question answering model. So in this case, the FuYu 8B model from Adept. And finally, we are doing a zero-shot segmentation model on this. So we are adding models, and we are dynamically composing all of these operators together to create custom workflows. And the great thing is there's all these plugins that already exist out there, these plugins which are in use by individual hobbyists, engineers, people at large companies and teams at large companies working together. And you can install any of these plugins that already exist with a single line of code or from the app, as we will show shortly. You can also build your own plugins and you can share them with the community. So it is incredibly easy to share the plugins that you build with the broader community so that other people can benefit from these things and other people can use them and share in the applications that you develop. Okay, we're going to now switch over to the app and we're going to get hands-on. Before I do that, I will take a second and look at the questions that have come in the Q&A. So the first question is about reading LiDAR info from phone images. So I'm not 100% sure exactly what you mean here, but you can have plugins that do data ingestion. So you can have a plugin that takes data from your phone on a trigger and sends that to some repository or some other bucket that then you can load in to your dataset on demand. The second question is Python scripts. You want to trigger and run this by running a button in the UI. Absolutely, 100%. And we are going to do that in the second part of the workshop. There is a question from Fernando about plugins that create custom views. Will it have access to the samples in the samples view and the ones that are selected? Absolutely. We will get to that in the second part of the workshop as well. Great questions. And these are questions that get at the core of what plugins can and can't do. Super important. Fortunately, the plugin system is flexible enough that it can do all of these things that you've mentioned so far. There's a question from Jim about are plugins making use of Apple's neural engine? I'm not 100% sure about this. There's likely a way that the plugin system can be made compatible with the neural engine. At present, it does not use the neural engine to my knowledge, but that doesn't mean that it's not possible. And then there's one more question. You can enforce that just one sample is selected. Yes, so you can have custom logic for the interaction. And if you look at the visual question answering plugin, which I showed, so we have links to all of these plugins from the FiftyOne Plugins repo, which Jimmy has or will share in the chat. So if you look at the VQA plugin in the FiftyOne Plugins repo, you can look into the source code in the init.py file, and you'll see the logic that actually clarifies basically if you have more than one sample selected, then it will send you a certain message. If you have 0 samples selected, then it will send you a different message. And if you have 1 sample selected, then it will actually expose the functionality for entering a text query and running the model. Awesome. Thank you, everybody, for the incredibly detailed and thorough questions. I really appreciate it. Okay, now we are going to hop on over to the FiftyOne app. So if you haven't already, please install FiftyOne. So pip install FiftyOne. This is free, it's open source, really easy to use. So here I'm going to open up my terminal. So I use Warp, but you could use iTerm, you could use whatever other terminal you'd like. And I'm going to enter a Python process. And I'm going to import FiftyOne. And then I'm going to launch the app. So just 2 lines of code, and we got to the app. So now we can select a data set. So I will be using the quick start data set. So if you haven't already, you should import FiftyOne, import the FiftyOne zoo as FOZ, and then download the FiftyOne zoo quick start data set. That is the data set that we'll be working with. But to be quite honest, the data set doesn't matter too much right now. It is just a way that we will use, it is a vehicle for exploring the plugin and operator ecosystem. So we're looking at the app. I assume that you all have been here before. I'm given that this is not the intro FiftyOne workshop, but something that you may not have played with so far is the operators list. So if you hit the backtick or tilde button on your keyboard, so this is in the upper left side of the keyboard, you will see a list of all of these operators that show up. So you have a description on the left-hand side, and then you have the name of the operator on the right-hand side. We're going to use a couple of these. So these are built-in operators that execute Python code. And these operators can have custom workflows. So, we'll show you the built-in ones, and then we're going to go bigger and deeper than that. But these are things that come built in with 51. So let's start. Let's choose. Let's see the clear selected samples one. So here, let me select a couple of samples, and then I will hit this clear selected samples one, and it has cleared the selected samples. Let's try another one. Let's say we want to delete samples. So let's actually select a couple of samples and we can delete them. And if you want to recreate these, then you can you can delete the data set and then re-download it or reload it. But for the sake of this, we will take these two samples and we will delete them. We can show them if we'd like, and then we can execute. We'll refresh the app. Let's do another one. We can clone a sample field. So let's take this clone sample field and we can choose file path. And as we interact with this, so as we chose the file path as the field, we get another field that shows up here. And we can choose the name of this new field that we are generating. So here, file path copy is the default that it goes to, but we can choose whatever we'd like. So we could choose my FP, for instance, and reload the data set. And now we have this extra field down here. That's great, but this set of operators that come with 51 is fairly limited. If we want to do more, then we can actually download the 51 plugins operators that come with the 51 plugins repo. So let's hop on over to the 51 plugins repo. So this is the repository for and the home for all things plugins. So this is the place that you will find all of the core plugins, Voxel 51 maintained plugins, example plugins, community plugins, everything. And we are going to start by installing these core plugins right here. So if we see, we go down right here, this shows us from the command line how we would download and install the plugins from this repo. We can do the same thing for any repo we'd like, and we'll talk about that shortly. But this is just at a high level what is going on when we are doing this operation. So let's copy this, and let's open up a new terminal, a new tab in our terminal. And we're going to be using the 51 command line interface syntax to do this download. So just as a refresher with the 51 command line interface, if we type in 51 here, we'll see a bunch of options. So these are all of the available commands. And the ones that we'll be interested in for this workshop are the 51 plugins, 51 operators, and 51 delegated. So that is right here. So it's these three are going to be the ones that we are using during this workshop. So if we type in 51 plugins, we'll see these are the options that we have available to us. If we type in 51 operators, we'll see some information. So here we can list out the operators. And we can see these are the operators that we have exposed to us right now. We can see some information about them, whether they're enabled, built-in, unlisted, or on startup. And let's do the operation that we came here to do, which is copy and pasting this and 51 plugins download, passing the name of the GitHub repo, and it will install all of the operators in that plugins repository. So now if we go back on over to the app, we refresh, and we hit the tilde button, we see a bunch more operators show up here. So we have installed plugins with one line of code, and now we have access to all of these additional operators, things for I/O, for annotation, evaluation, for running models, lots of things. So let's just look at a couple of these real quick. We can do things like, we go down here, we can look at these examples. So there's an example of opening a panel. There are examples for simple messages. So these show you the different formats of messages that you could work with. There are examples for looking at, for instance, settings. So I can look at the settings for one of my data sets, and we get a bunch of information about it. Now, in order to install the plugin for these operators, we had to go to the command line, and we had to enter this command line interface syntax to download and install the FiftyOne Plugins repo plugins. But moving forward, after we do this, we do not have to do that again. We can instead use the install plugin operator that comes with the FiftyOne Plugins repo. And with this, we can install plugins from GitHub. So you can do this from a GitHub repo, from the URL, from a reference, or from a ref string. You can do it from the Voxel 51 plugin. So this is the core Voxel 51 maintained and example plugins in that repo. Or you can do this from the community table in that repo. So if you create a community plugin and you would like your plugin to be accessible to everybody else, all you need to do is submit a PR with a new entry in that table for the GitHub repo with your plugin, and your plugin will be able to be used and downloaded without even writing any code to anybody else. You don't have to. You can write plugins for just you to use, but if you want them to be used by other people, it is incredibly easy to do so. So if I click on this community tab right here, I can see a list of all of the plugins, and this is dynamically generated based on the README in the FiftyOne Plugins README and repo. And this table is basically parsed, and all the information about the plugins is extracted, and we can click on one of them. So let's say we want to click on, for instance, this image issues plugin. We can hit execute, and we refresh. And now we will have a bunch of additional operators for that plugin available to us. So it was that easy to install a new plugin once we installed the FiftyOne Plugins plugin. We can also look at the requirements for any of our plugins. So if we look at the Manage Plugins operator here, we can see which plugins we have enabled and disabled. We can change that. So we can disable something or enable something else with a single click. And if we go back here, we can go to the Requirements tab. We can choose a plugin. So here I can choose the Image Issues plugin. And I can see that the requirements, the version of 51, as well as the requirements for this plugin, the OpenCV Python headless and Pillow, I both have installed already. So this is fine, but if I did not have those installed, then I could install those or upgrade the versions or however else I'd like. Let's download one more plugin. So let's download the, go to install, go to the community, and we will download the YouTube panel plugin. And we refresh. And let me go to manage. And let's see what's going on. If we enable this, and refresh again, we see a button here for this YouTube player that appears in the app. So with just a few clicks, you can add additional buttons, additional panels, whatever else you'd like to your app. And now clicking on this, we can again, play these videos or, interact with it. Now let's go back to our other operators that execute Python code in the background. And again, very shortly, we'll be talking about what is going on in these, but let's look at, for instance, evaluate model. So this is one of the plugins, one of the operators that comes with the 51 plugins repo. And let's just call this eval. And the predictions field we'll say is predictions, and then the ground truth field we'll say is ground truth. And we get all these additional methods that come up, but let's not touch any of those. Let's just hit execute, and notice here we get an option for delegate execution, and this would allow us to have the execution basically queued so that we could then launch it moving forward. And we will do that with another thing very shortly. But for now, let's execute this. And this is going to run a Cocoa style evaluation on our predictions with respect to this ground truth field, all from the FiftyOne app. And we see that just like that, we have this additional set of eval true positive, eval false positive, eval false negative. And even if we go into our individual predictions here, we can see now that on these predictions, we have these true positives and IOU scores associated with them. So now let's use the image quality issues plugin. Let's just compute one or two things real quick. So if we go to type in common, and then we go to blurriness, we can choose either a patches field, so either our ground truth or detections, but we're not going to do that. We're just going to choose all of our samples and have this computation for blurriness done over all of our samples. But in this case, we're going to delegate the execution. So by clicking the box here, we can choose to have this task delegated. And then it says you must have a delegated operation service running. So you can either have an orchestrator that you work with, or you can have this just on a separate, basically a separate process on your local computer. And that's what we're going to do here. So I'm going to schedule this. And then we're going to go back on over to the FiftyOne, or to the command line, and we're going to use the FiftyOne command line interface syntax with FiftyOne delegated. And we're going to list all of the delegations that we currently have. So here we can see that we have queued an operator. We have queued this operation. We have an ID. We have the operator that was queued, the data set on which it was queued, the time, and the state. And with just typing in FiftyOne delegated launch, we can start the service and have this computation run. So here we have operation service running, and then it completed very quickly because there were only 200 roughly samples in the data set. But for a larger data set, for more compute intensive and time intensive tasks, we would want to do this. And this would actually be something that we would need to potentially run a delegated operation for. So now we can X out of this, go over to the app, refresh. And now we see, in addition to the fields that we had before, we also have a blurriness field. And we can filter this blurriness field. Awesome. Now we'll get out of that. So I hope this showed you just how easy it is to take plugins that already exist and to install them, to make sure that the requirements are all already satisfied, to use them in your workflows, to mix and match them, and basically to reduce the amount of code that you have to write to do whatever you need to do in machine learning and computer vision. So we're about to switch over to the developing FiftyOne plugins section of this workshop. Before I do so, before we take a quick break, I'm going to look at the Q&A. There's a question about changing the shortcut for the operator list. At the moment, I do not know if there is. For a question like that, I would ask I would go to the FiftyOne plugins channel in the FiftyOne Slack community. It's a great community of people who are very eager to help, and they're all incredibly excited about computer vision and machine learning. If you post the question in the plugins channel there, you will likely get a very quick response about this particular question. There's a question about default licensing for the plugins. Every plugin has its own license. You don't have to include a license, but you can. That is one of the optional files that you can include in a plugin. At the moment, I don't think you can check what the license is via the UI, but that is a great point, and that is something that I could see the use for 100%. So again, post this in the FiftyOne plugins Slack channel, or you can post this in feature requests Slack channel. There are many places to get the word out about that, and I could see that being an incredibly useful thing, not just for you, but for the larger community. Are all community plugins open source? Another great question. What we call community plugins are plugins that are listed in that community table in the FiftyOne plugins repo. So those are all open source. They need to be open source to end up being downloaded to everybody's local computer. You do not need to open source your plugin. So there are, if you are working in a larger organization and you want to keep your plugins for that organization secret, you can do that, and you can have the plugins be installable via a private GitHub repo. And there's a syntax for installing from private GitHub repos if you have the proper authentication for that. Which key are you using to refresh? I was just using the command R to refresh. And then what is the shortcut for opening plugin entry panel? So I was clicking on the backtick or tilde button. So it's the little squiggly button. If you see, there's for one of our, it's basically like half of an approximate, or it's like a similar sign. All right. So while we're on our quick break, if you are interested, here are a few tips and tricks that are helpful for using operators, delegated operators, and plugins. You can set the operator timeout duration. So this is in your FiftyOne config file. You can do this by exporting it as a variable or by setting it directly in Python. So the default is 600 seconds, but you can choose whatever you'd like. You can also execute operators via the Python SDK. So there is a standard syntax for doing this by passing in the context and then using the FOO 51 operators that execute operator method right here. But there's actually an even simpler way, which we can talk about if you'd like, but you can basically define a call method for the operator and specify what the arguments are and make that operator callable via Python code. For delegated operators, you can filter the list of delegated operators that you get in the command line by things like the dataset name, the operator name, the state, whether it's completed or whether it failed or queued. You can sort by certain things like the time that it completed at, and you can limit the number of results that you get. You can also manually mark the state of a delegated operation as failed. So this could be helpful if something potentially ends up continually running and it's going to take a long time to finish, way longer than you initially thought. And you might want to just call it quits and say this failed and then delete it. You can do that by using the FiftyOne delegated fail and then passing in the ID of the operation. You can also use an orchestrator. So FiftyOne supports using Apache Airflow in conjunction with your delegated operations. You can set this up. There's a full documentation page about this in the FiftyOne documentation. And this allows you to orchestrate and to basically have more control over the way in which your delegated operators run and execute. And if you want this to be even simpler, you can use FiftyOne Teams. So FiftyOne Teams offers a ton of functionality to teams that are working together in order to collaborate, version, permission, and work with cloud-backed media natively. There's also this native support for managing the runs from your orchestrations and delegated operators within the app. So if you want to make this even simpler, then you should check out our FiftyOne Teams documentation and page on the Vox 51 website. For plugins, you can also list a plugin's secrets from the command line. So one thing that we didn't talk about, but which is a little bit more of an advanced topic for plugins, is when you are using delegated execution, you are working potentially in a different environment than you are when you are running the app. So the environment variables and different things that your new environment has access to may be different than what they are in the initial environment from which you queue that job. And you can securely pass relevant environment variables, relevant API keys and tokens via FiftyOne secrets. And you can list out what secrets, not the actual values, but the names and descriptions of those secrets via the command line. And as I mentioned, you can download plugins from a private repo with your GitHub personal access token. Finishing this up, you can specify the plugins directory with an environment variable. So far today, I have been using the default plugins directory for this demo, but in general, I actually use a different plugins directory so that I can both use plugins and develop plugins with the 51 plugins repo, but you can set this very easily with an environment variable or within Python. Okay, going to take another minute or two of break, and then we're going to talk about developing 51 plugins. And there's one more question that came in, so I will answer that. At the moment, Apache Airflow is the only thing for which there is extensive documentation, but that does not mean it is the only thing with which you could actually orchestrate. 51, if you look at the GitHub repo, which is open source, there is an orchestrators file or an orchestrators directory, and that will allow you to basically define your own orchestrator if you'd like. And yes, this is being recorded, and this will be available on the the Voxel 51 YouTube channel shortly after this is finished. There will also be a summary blog post that goes along with this, and then the tips and tricks that I mentioned will be made available as well. All right. So thank you for staying with me to part 2 of the workshop. We're going to talk about 51 plugin developments now. So we're going to get a bit nitty gritty for a second. We're going to talk about the anatomy of a plugin. So how is a plugin actually constructed? And we're going to do this by looking at 3 examples. So here I have 3 example plugins. One, which is a plugin that comes with the 51 built-ins. One, which is the image quality one that we looked at before that we just downloaded, and then the zero-shot prediction plugin, which I showed you some GIFs from. So I've printed out the list of files for the plugins directory for each of these. So we have all the files that go along with the Hello World plugin, the image issues plugin, and the zero-shot predictions plugin. And we're going to talk about what is going on in these files, what you need to have in each of them, and how you can actually build your own plugin. The first thing that you need is the 51 YAML file. So this is absolutely necessary. You cannot build a plugin without this 51 YAML file. You need this in every plugin, whether it's a Python plugin, a JavaScript plugin, or a joint Python and JavaScript plugin. And this basically registers the plugin with 51. So it declares the plugin. You need to specify the name for the plugin, and you can specify a bunch of other information from the author, the version, the operators that are in there, the secrets that go along with that. Basically, this allows you to register all this information along with the plugin. And here's what it looks like. So for the annotations plugin, this is a plugin that is from the Voxel 51 plugins repo. You have the name here, which is at voxel51/annotation. And typically the way that the standard that we use for creating plugins is you put first the @, followed by the name of the organization or the person, the GitHub repo that it is associated with, and then the name of the plugin itself, a description, the version, the 51 version, URL, the license. And so you can get this information. If you look at, there was a question about licensing. You can get, if there's very, very brief information about the license, you can have that produced here, and that will be able to be seen via the command line as well. But you can't have like the full license information printed out at present. You have the operators here, so requesting annotations, loading annotations, getting annotation info, and so forth. And you have this list of secrets. So these are the environment variables that are passed along in a secure way to the new environment where you are running delegated executions. The next file, which you need to have for Python plugins, is an init.py file. So here, all these plugins have a Python component to them. So they all have an init.py file. And within this, this is required for Python plugins. Within this, you need to define in an object-oriented fashion the operator. So you basically create a class object for this operator and you can have multiple operators that you define in a single plugin. You can specify all this information about the operator, and we're going to go deeper into what the information is that you need to include and what you can include for any particular operator. And then you, at the bottom of the file, register these operators with the plugin. So here we are registering this count samples operator, which is going to count the samples in our dataset or in our view. You can also specify a requirements.txt file. So here we see it's only present in one of the three. And this is for Python plugins. It specifies the Python modules that are required. And when you use the ensure requirements or check requirements tab from the manage plugins operator, this is what will appear there. So if there are things that are listed in your requirements.txt file, those things are the things that will be checked by the ensure requirements and from the command line as well. Likewise, you can have a package.json, which specifies JavaScript plugin information. I'm not going to go too deep into this. You can also have an index.umd.json, which is .js, which specifies the JavaScript bundle. And when you put it all together, you get something that looks a little bit like this. So you would have your plugins directory. You have a JavaScript plugin, which has the, again, 51.yaml file, which you need for every plugin, your package.json, your source, which includes your TypeScript files. So we use TypeScript to create the code for the operators in our JavaScript plugins. We have our Python plugin, which includes the 51.yaml, the init, and the requirements. And we're not going to talk about JavaScript development here, but the key differences for developing a JavaScript plugin are you need a source install of 51, and you need to run yarn build to create the plugin initially. And then if you want to dynamically work with and update the plugin and be seeing the results of your dynamic changes in the code manifested in the app, you need to start a server with yarn dev. I'm not going to talk about this, but these are the differences. If you're working in Python, you do not need a source install to actually develop a plugin. So going a little bit deeper on the operators. So what are the things that you need to include and you can include when you are constructing an operator? And we're going to focus on Python here, but this is almost identical for JavaScript. At the very top, you have the configuration. So this is a property of the operator itself. It specifies a bunch of information, whether it's dynamic, whether you start it, whether you run the operator on startup, things like that. Icons that you can associate with the operator. You also have a context. So this is a dynamic context which is passed into all of these methods. And then you have these methods, some of which you need and some of which you don't need. So for the placement, this specifies if you want to put a button in the app, you can specify what inputs you want, what outputs you want to be given by the operator, what you want to happen when you execute the operator, and then how you want delegation to be handled. The config looks like this. It takes in the name and the label are required. So you need to name the operator and you need to have some label that actually is what shows up when you see the operator. You can have a description. The operator can be dynamic or not. You can execute it as a generator. It can be listed or unlisted. It can happen on startup, and you can have icons associated with it. And here on the right-hand side, we have some of these icons. So we have custom icons for all of these operators. The execution context is what is passed into all the operators' methods at runtime. So we have the parameters. So these are the dictionary containing the operator's current input parameters. So as you specify inputs that are taken from the user in the input form, the values of those inputs are stored in this context.params dictionary, and those are then accessible to all the other methods. You have a dataset name, the dataset. So this is the instance of the dataset itself, which you have access to. The current view in the app, same as with your 51 app session, you will have the, like you have session.view, you have, context.view. Same with selected and selected labels. The same way as you have the session.selected and session.selected labels, you have your context.selected and context.selected labels. You have these secrets, and you have the results. So the results is a dictionary containing the outputs of the execute method. You can define your input via the resolve input method. So here we have an example where we are seeing a little text bar where we can enter my message, and then we get an output corresponding to that. But this is just showing you an example of taking a single input. And on the right-hand side here, we see how you actually code this up. So we can have this resolve input method, which has the self for the object itself, and then the context, the execution context, which is passed in. We have the inputs object, which we're defining, and then we have a string, which we're taking in from the user as this message. And then we are basically formatting how we want that to be displayed. There's also a very rich type system. So you can choose how you want things displayed. So, and this is an example on the right-hand side of one of the components in the FiftyOne Plugins repo that comes with that. So this is the build component operator. And this shows you how to dynamically change between different ways of viewing certain types of input. So here, if we look at the radio group, so this is things from which there's multiple choices and you can select one of them. There are multiple ways to visualize that, and you can dynamically see that updated in the app. Same with Booleans and floats and messages. The same with input, you also have an output, which you can optionally define with the resolve output method. So here we are looking at the get brain info operator, and we are putting some inputs in, and we are seeing some formatted output about that brain run. And we see all this information here, and this is all that it takes to specify this on the left-hand side. You can specify the placement, so you can specify how the operator manifests visually in the app. It can be as a button in the samples grid, a secondary button in the samples grid, the sample viewer actions, the embedding actions, histogram actions, or map actions. This can be prompted or unprompted, and there's a lot of flexibility here. This is all that you need to actually specify the placement. So here, this is an example of where the button shows up if the dataset name includes the word emoji. So if I'm on this quick start dataset or the Cocoa dataset, then there's no emoji button. But when I am on the emojis dataset, I do have that button that shows up. And from a code perspective, all you need is this block right here. For execution, this is required because all operators must trigger some type of work. So the operator's main actions are encompassed in this execute method. This can run computations, query your data, add samples, and so much more. You can compose operations together with the trigger method, and you can execute these asynchronously or as a generator if you'd like. So here's an example from what I showed you earlier, where we are adding a sample to the dataset by calling a text-to-image model, and then having that dynamically added to the dataset when we hit the execute for this particular operator. And delegation. So you can optionally specify how you want your operator executed with the resolve delegation method. And in this case, we are actually giving the user a choice. So this block of code right here specifies what we're seeing around this checkbox. So we're checking a parameter, which we pass as input to the user, asking them if they want to delegate execution or not. And then we are going to delegate based on what the user selected for that option. Okay, that's enough from the theory perspective. Let's dive in and actually build a plugin. So the plugin that we're going to build is a double band filter plugin. And by that, what I mean is we're going to basically specify two distinct numerical bands and have the plugin filter for all numerical values that are in either of those bands. So it is pretty easy to, with the sliders in the app, to filter for things that are in one band or they're on one side of a range. But there currently is no way within the app to actually filter for two bands simultaneously. We're going to do that. So we're going to need to have a selector for the numerical field. We're going to need to have inputs for the left and right sides of each of the bands. And then we're going to need to implement the logic around setting the view. Before we do that, I'm just going to look at the Q&A one more time. There's a question about computations on GPUs. If you delegate your executions, then yes, you can absolutely do that. And even within the app, you can specify the number of workers for certain processes. There are some complications around these things and what operations happen in parallel versus synchronously, but yes, those things are possible. If you want to build a plugin that is just JavaScript code, with the sample, you embed an iframe. There's a question about executing code in Python, or if you need it to be in JavaScript and TypeScript. At present, to make things dynamic, including iframes, you do need to have JavaScript. But if you want to have, so one thing which will be coming very soon is Python panels. So that will really up the flexibility for writing Python-only plugins. But at the moment, if you want to do things with iframes, embedding, and making your own sample visualizers, even if you just want to execute code based on that, you do need to have those be TypeScript, JavaScript plugins. Awesome. So we're going to go on over to the app one more time. And we're going to pull open our list of operators. And fortunately for us, there is an operator which allows us to build an operator skeleton. So this is the place that I start whenever I'm building a new plugin. It basically reduces the boilerplate code that we have to write and lets us focus on the logic of inputs, outputs, and execution. Basically, it makes it even simpler to write a plugin than it would have been if we had to copy over all those little blocks of code from what I showed you earlier. So this is going to walk us through the process. We can configure the configuration for the plugin, or for the operator, and the placement. So in this case, let's say I want to call the operator, let's say match either band, because we want this to match one of two numerical bands that we're going to give it. We'll call it the match either band operator. And then the description we'll give it is, we'll say filter dataset for values in one of two ranges. Let's say for now, we do not want an icon. We do want this to be dynamic. So this is going to change based on how we interact with the app and what happens with the dataset and the view. We don't want this to be executed as a generator. We do want it listed. We don't want any of the other things, and we don't want it to be a placement. So we don't want it to occur as a button in the app. We can change all these things later if we want. This is just going to help us to get set up. We will want input. So we're going to need some input from the user in order to specify, and that user can be us or someone else, to specify what the field is we want to filter on and what the numerical ranges are for the left and right band. But we do not want output, because in this case, we just want to execute some operation to set the view. For execution, we do want a trigger. So in this case, we want to trigger another operation to occur after this is finishing, and this is going to be setting the view. So we're going to want to set the view with whatever this filtered operation is that we're going to generate. And we do not want to delegate this. So we can look at the code before we actually create it. And here we're seeing what's going to be in the init.py file. We have this match either band operator here with what we configured, resolve input, and this is going to generate the code, but it's not going to create an entire plugin for us, because We actually need to still put our logic around the inputs and the execution ourselves, but this is not going to throw any errors. We're going to have in our execute method this dummy view, which is going to take our data set from the context and then take 10 random samples from it. And then we're going to trigger a set view operation from there. And we're registering the operator with the plugin. And then we can create this. So as I mentioned, the standard that we use is, hold on, let me get rid of this. The standard that we use is we are going to have the GitHub repository for the organization. And that is going to be the first part after the @ symbol. So we'll just do match either band. And then one of two ranges. And go back and do this. Input, trigger, set view, and then look at the create. That's my GitHub repo in here, and then we'll call it double band filter, and then we can put whatever we want for the plugin description. So filter a float field on 2 bands. And then we're going to put this in our plugin directory. We're going to specify this is going to be in the directory, subdirectory, which is my name. So this is your GitHub repo you'd put here, and then the name for the subdirectory for that plugin. So we'll call it double band filter. And we can hit execute. And now if we refresh the app, we should see we have a new operator here for double band filter, match either band. And this is not going to do anything right now because we don't actually have any logic to go along with it, but we can create that logic. So to do that, let's open a text editor and actually open up the code for this plugin. So let's go over to the terminal and let's go to the directory where we have our plugins. And if we don't know that, we can look at the 51 config. And we can see our plugins directory is listed here. So in this case, I'm going to go to the plugins directory for me. I'm going to look at my plugins, and then I'm going to look at the double band filter one that I just created. I'm going to open that up. So I'm going to use VS Code, but you can use whatever code editor you'd like. And here we can see the code. So now we can specify all of the inputs and execution logic. We can see as we do this, we're going to dynamically change what's going on with our operator in the app. So to start out with, let's take some inputs. So let's use our build component operator to help us to create the components of input that are going to be used in our operator. So let's go to the build component operator. Let's first take a message. So we're going to output this as a message to the user. Let's say we want this to be a header, and we'll call this filter on either band. And we'll say specify the field and the bounds. And we're going to take this code. We're going to copy and paste this into our inputs here and format it. We're going to save. We'll go back over to the app. And I refresh. And now if we go to our double band filter, we see that message is displayed right here. Now let's add our inputs. So we're going to need a few things. We're going to need the field, and we're going to need the ranges. So the first thing is the field. So for the field, we're going to need a top-level float valued field. And in this case, we actually have two of them. We've got our uniqueness field, which comes with the quick start dataset. And we have the blurriness field, which we computed earlier. But we don't want to specify these by hand. We want to have these systematically generated for us in a list. So Here, let's reset. Let's look at our build plugin component operator, and let's get a list. So this is going to be, we're going to choose one from a list of options. Let's have this be represented with a dropdown, and we will have it be required because we do need the user to specify one field in order to actually run this computation. We're going to copy and paste this code. I'm going to add this in here. And in order to actually specify what this field is, we're going to have some logic. So instead of this for my choices, let's make a really quick utility that does that for us. So let's create a function which is get float fields of our sample collection. And we're going to return, this is going to be a list. We're going to take in our sample collection. FiftyOne has this get field schema method, and you can pass in the field type. We want these to be float fields, and we're going to get the keys from that, and then we are going to get the list of that. So just to see what this looks like, we can go on over to our Python process, and we can get a dataset here. Dataset is 51.load dataset. Click start. And we can look at the dataset.get field schema. And we can look at the float fields from this. Float field. So we get the uniqueness here from this, but we would also get the blurriness and whatever else we'd like. Okay, so here, if we go on over here, we have this list of float fields. And now we're going to, instead of this dummy list, we're going to get our float fields and we're going to pass in the context.dataset. So we can also name these things to make the names of these variables more appropriate. So this would be float fields. And then this would be here for choice in, and this would be for FF in float fields. And then we'll call this field radio group. And label is equal to FF. Let's see what the issue is. My radio group is not defined. So that's actually going to be this right here. And let's go on over to the app and let's see. So if we go to match either band, we should have a list here, and we have uniqueness and blurriness to show up for us. So just like that, we were able to get a list of all of the float fields in our data set. We can select whichever one we want, and then we can use that later on in our execution. Now we need to get the inputs. So we're going to need to get the inputs for the dynamic ranges, the ranges for the two bands. So those are going to be four separate numerical values. And if you were actually to make this plugin more robust, you would want error handling around the values of those, whether they're more or less than the minimum and maximum for the ranges taken by that particular float across the data set or the view that you're looking at. You'd want some handling around whether the ranges are overlapping and the left is less than the right. But for this very, very brief example, we're going to skip all of that and we're just going to do the basics. And the basics are, if we go to the build component operator, we look at the float, and let's say we want a field. We don't want a minimum, maximum step, or default. We just want this bare bones code right here. We're going to pass this in. And while we're at it, we can change these things just to make them more representative. Float field, and then we'll call this field to filter. And then we'll say select the field to filter on. And then we'll call this one, this is going to be the first of the numeric ones. So we'll call this left min. And we'll say this is the minimum value for the left range. And now we want to do the same thing for the left max, for the right min, and for the right max. Refresh, and we'll go to match either band, and now we have this whole set of inputs. The last thing we need to do is we need to actually do the execution part of this. What is the logic to take all these inputs and to create a view that we want to set in the app? So for that, we are going to head on over to the execute method. We're going to put our logic in here. So in this case, we have 5 inputs, and these are all going to be in the context.params dictionary. So let's call it the float field equal to the context.params. And then we'll do dot get, and then this is going to be float field. And also notice that we need to specify required for all these other float fields. And this is going to ensure that we are actually getting a value for these. You may not need a value in your case, but in this case, we do want one. We have our float field, and then we're going to have our left min, our left max, our right min, and our right max. So we have all of our inputs that we have extracted from that, and that we can now use as values, as variables in our logic to create the view. So instead of this dummy view to take the data set and get 10 random samples from that, let's create our filter. This is going to use FiftyOne's filtering. So let's use the view field. So we're going to, from FiftyOne, import view field as F. And let's create the left filter. So the left condition is going to be something like this. The float field is going to be greater than the left min, and it's going to be less than the left max. So that's going to be if this is in the left band. And then the right condition is going to be something like this. So it's less than the right min, and it's greater than the right min, and it is less than the right max. So the left condition is if it's in the left band, and the right condition is if it's in the right band. And on the whole, we want this to happen basically if it's in either band. So we want the view is ctx.dataset.match, and then this is going to be the left or right, because it can't happen for both at the same time. It needs to be for one or the other. And let's X this out, and let's get rid of that. And now we have this trigger set view for the view that we just created. So let's do it. Let's go back on over to the app. And just to show you that it's working, let's open up a histograms panel. And we will do this to the uniqueness right here. And now let's do a filter. So let's do our double band, and let's choose the uniqueness field. And so let's say the left min is going to be 0.1. The left max is 0.2. Let's call the right min 0.8. The right max 0.9. And we see that we got a subset of the values in just these 2 bands right here. And the view dynamically updated, and then the histograms panel dynamically updated too. And you could make this as complex as you want. You could add all of the error handling for all of the values. You could make the way that they visualize in the component much nicer and more aesthetically appealing. You could even add another operator to this plugin that would open the histogram panel on launch that would allow you to basically have this dynamic workflow much more uh, as the standard for all of this. There's really an infinite number of ways to go with this, and this is an incredibly simple example, which is why we were able to build it in like 5-10 minutes. But I hope this shows you just how powerful and easy to work with the plugin ecosystem is. So that's it for building the plugin. We're going to go back over to the 51 or to the slide deck, and we're going to finish up here. So once you've built your plugin, you can publish it. You can either keep this as your own plugin that you only use, or you share with other people via a private GitHub repo, or if you have a zip file for the plugin, you can share that zip file, and then people can upload and install that zip file. But if you want to share with the community, you want this to be used by other open source users, other enterprise users, people in the broader community, you can make a PR to the 51 plugins repo, adding a entry to the community plugins table. It's this easy to do it. And to finish off, just some quick tips and tricks on developing Python plugins. There's a really rich type system that allows you to build stunning UIs. So there's things like progress bars and Plotly integrations and lots of other things. And if you want to really dive into these, you should check out the documentation around the 51 operator types API. If you want to import other modules into your plugin, you can do that with lazy imports and environment variables. You can add additional modules. So in some of the plugins, I have additional Python modules within that directory. And you can do this by locating with the add_sys path utility the directory that your plugin is in, and then importing from there. You can add caching. So every time the Python plugin reloads, the init file is like re-instantiated. So in order to have caching in your Python plugins, you'll need to have a separate module, and these separate modules are not reloaded every time. So you can actually cache things and store values in there. These can be user preferences or information about something that you want to be saved and kept live over time. And for developing JavaScript plugins, you can, and what I find easiest to do is to open panels and to do things like finding the URLs of samples within Python and then passing that information into JavaScript as opposed to trying to do everything in JavaScript. You can also add node modules as dependencies. So if you go to the packages.json file, you can add here, and in this case, we added the React drop zone module, and that's what we use in order to drop a file from our directory in and do a reverse image search with respect to that. You can also add plugin icons, so you can specify the light and dark icons or just a generic icon for each operator. You can edit the icons with your SVG with a text editor. You can change their colors to remove text and stuff like that. You can even specify separate operators, separate icons for the operator and its placement. So where it occurs in the app and where it occurs in the operators list. And just to conclude with some next steps, I will take the question that we have here in a second. But if you'd like to build your own Python plugins, here are a few quick examples that I think are great things that would be beneficial as learning experiences for you and also would be great for the community to have. So things like outlier detection, mask smoothing routines, image matting, drift detection, and in general, adding any foundation models for vision or other machine learning tasks. These are things that would be tremendously valuable to the broader 51 and computer vision community. And I think they would get a lot of traction in the 51 community ecosystem for plugins. If you want to dive deeper, you should really just explore and try to download and play around with the plugins that currently exist in the 51 plugins community ecosystem. Build your own plugins and publish them. Really, I'm going to hammer this over the head. It will be awesome. The more plugins we get, the more people are going to be interested. And there's going to be a lot of usage from tons of people all over the place. This is just going to be an incredibly, massively growing community and effort. You can create custom JavaScript plugins with panels and visualizers. That's a good next step. And you can also contribute to the 51 plugins framework itself. So what I've talked about today is about using and building plugins, but the framework for 51 plugins itself is open source and highly encourage contributions to that. If you'd like to read more and to get more into FiftyOne Plugins and FiftyOne as a project more generally, I encourage you to check out the FiftyOne plugin documentation, to join the plugins channel in the FiftyOne community Slack. And if you like our work, please give us a star on the FiftyOne project. It's open source and it helps us to continue to do great things like delivering these workshops. And last call to action is please give us a star. Follow us at Try51. You can go to try.51.ai. It's free. You'll get to play around without even downloading anything. And we have 2 events coming up tomorrow. One event coming up in an hour and a half, and one event coming up tomorrow. The first one, which is in an hour and a half, is going to be on transforming computer vision with large language models with Data Science Dojo. And then we have an event tomorrow in Sunnyvale with Google Developer Group's DevFest on vector search for data and model understanding.